Hi. So I'm going to be doing this lecture remotely because I'm going to be gone for the day. So this is as part of the Martin Luther King Jr. teach-in session. So what we've done is we've taken different teachers, have tried to teach on something related to MLK on this day. And so what I picked was to discuss how algorithms and technology can be biased, specifically biased more toward minorities or disadvantaged people of different kinds, whether it's due to gender, age, whatever the case may be. So I've collected a few different stories here, talked about how it happens, and part of the reason I feel this is such an important topic is because I teach math after all, because I teach business methods and models. It's important to talk about how they can be misused as well as how they can be properly used, so that you're aware of ways that they can be misused. And I asked for apologies in advance. It's the first time I'm trying the studio, so there's going to be some zooming in and out. There's going to be some factors there that are going to be complicated. Okay, so what I've done is throughout I've inserted some interesting quotes by MLK for you to read. So here's one of them that I like a lot. The idea being, this is from one of his sermons, the idea being that it's more than just about kind of analysis and knowing the right answers, and that we truly have to think about humanity as well. And with some of the recent controversies about Facebook and other tech companies, this has become, again, more important than ever, that we're using these technologies properly to benefit humanity. So let's talk first about what an algorithm is. So the concept is, one way that algorithms can help you is, let's suppose you're doing hiring for a Fortune 500 company, and this is where it could become useful to you. You have thousands, perhaps tens of thousands of resumes to sort through. You don't know really how to start. It's going to take you several minutes, even if you read them relatively quickly. It's going to take you maybe at least a minute per resume. Think about opening it, checking it out, closing it. And you can't just search necessarily for one key term in the resumes, right? So if I need to hire someone for a certain job, and I just search for Excel or Python knowledge, it might take some time for me to get that particular factor and find it in the resumes and do it in the right ways, especially if I want a combination of several factors. So an algorithm could work in such a way that it would find the best combination of resumes that have just the right amount of key terms. So maybe the most simple type is, I'll give you 1 point if you say Excel, I'll give you 2 points if you say Python, I'll give you half a point if you say bachelor's degree in business. You get the idea. So I could use an algorithm to add up, give people various points, cycle through the resumes, and either eliminate low-value resumes, so I only have a few to look at, or, most likely, find 10 or 20 or 30 high-level resumes that I want to talk to those people more closely, and I want to investigate that for myself. So it all sounds pretty good. And you can also get the idea as well. The algorithm could be used on whatever characteristic you want. So if you want to highlight GPA, if you want to highlight work experiences, whatever the case may be, you could do so. However, one thing that you should be concerned about is that algorithm favoring anyone in particular? So here's a quote from Cathy O'Neil I like. Too often we trust math too much because we think that it leaves human bias out, but humans, of course, are making the models. So we'll talk about this, for example, when it comes to loans. What determines if you get a house loan or not, right? Clearly, sure, the computer or the bank is saying it, but they don't necessarily have the full answer themselves. It's being done through some sort of calculation that a human created, that a human put together. We're not quite at real artificial intelligence yet, and even that artificial intelligence would be human influenced. So here's an example. Let's suppose that you're trying to do an algorithm that would tell you how much money a movie would earn. And so this is a pretty simple idea. So I have a movie there that I think could earn a fair amount of money. And so the highest level would be it gets consumer engagement points according to this model. And so with its consumer engagement points, if it gets 500 points, I think it's going to make at least $180 million. Great. It could make, if it's a little more low level, it can maybe only get 300 or 250 points. It's going to make only 50 million, 20 million, so on and so forth. And below 100 points, it's just an indie film. It's not necessarily mainstream at all. So this sounds like a very logical method, and the way it works is, figure out what category it's in, who's in the movie, what their skills are, what their previous achievements are, the director, look up previous films, and come up with a scoring method. And I'm going to zoom in. You can see some past films, what they scored, and whether you would agree. So here's some of their top films they've chosen. And as you can guess, some of these look like a great idea that the algorithm has worked correctly. Others didn't do necessarily so well, and you might disagree. So one natural one is Office Christmas Party is ranked rather high. That movie did not necessarily do so well. Similarly with Assassin's Creed. But the key is also that perhaps this would show you some movies that were underrated. So for example, Hidden Figures shows up pretty well on this. If you look at some of the movies under Hidden Figures, they include Passengers, they include Loving, and some Allied, and some other movies that you think perhaps had a little more buzz than Hidden Figures. So it does do a pretty good job of predicting a movie that was a little underrated going into the box office that did pretty well. So these algorithms have gained a lot of our trust by finding answers that we weren't necessarily looking for, even though sometimes they seem to make mistakes. So we've established that algorithms have some use with resumes, with movies, but let's start talking about some of the flaws that could lead to bias before we get into biases themselves. So here's one example. Suppose that I've created for an NBA team, so you can pick the Sixers if you'd like, your hometown team, and suppose you pick this algorithm and say this algorithm should only pick players that have a certain body type for different positions. So if it's guard, which is usually slightly smaller players, I'm going to try to draft players only 6 feet and over. And if it's forward center, I won't consider anyone less than 6'6". So you would think that this would be successful because it really targets the heights that are most important. But what I want you to do is think a little bit about what this might actually work like, which players it might underrank. So there's one or two natural examples. If you think of Isaiah Thomas, the short point guard who had such a good 2 years or so for the Celtics, he was drafted last in the entire draft, and yet he was a very successful player there for a few years, although right now he's injured. But there's even some other more logical players that this algorithm would leave out. So I have a funny example here. If you look closely, you'll recognize one of the players in the photo for sure. So those are several different Sixers greats over the years, and one of them is well-known Julius Erving, but the other one is Charles Barkley. And Charles Barkley was always rather short for a forward. Sometimes he was listed as short as 6'4", which according to our model, 6'6" and higher is who we're supposed to draft. So then the Sixers would have never drafted Charles Barkley using our particular algorithm. So what's the problem with our algorithm? Why would it exclude Charles Barkley even though he was quite a successful forward? Well, one funny quirk that I'd like to tease a little bit, so if you look at Charles, he doesn't have much of a neck at all. So 2 or 3 inches there that a man of normal height and neck size would have, Charles doesn't have. But that means that if you look at his shoulders, they might be more the shoulders of someone who's 6'6" in height, 6'7". So even though his overall height is small, that's more a little bit about the size of his head and his neck being smaller than average than his actual body. And obviously your head and your neck don't make an impact on how you play on the NBA, it's your body and your frame. So this algorithm, through kind of no fault of its own, would have said don't draft Charles Barkley, although he of course is a legend. So that kind of gives you kind of a more innocent look at how algorithms could unfortunately have bias and neglect people who deserve better. But let's look at unfortunately a little bit of a darker side of all this. So this is the movie Minority Report with Tom Cruise. I'm going to play a little bit of the trailer for you. And so this is, of course, imagination, science fiction, but before we get into kind of the dreary realities of why this can be so bad, I want to focus a little bit more on a hypothetical movie. So what happens in this movie is that, and I'll play some of it for you right now actually. I'll switch to screen. So what's happening is that the system is so successful in finding future criminals that of course everyone starts trusting it to find future criminals, and Tom Cruise is essentially a cop who helps make it happen, and then naturally the problem is that everyone trusts it too much and a penalty occurs. So I'm going to play a little bit of it for you.
future murder of Sarah Marks. Who demands that?
The future can be seen. All we have to run on are the images that they produce.
We see what they see.
There hasn't been a murder in 6 years. There's nothing wrong with the system. It is perfect.
I agree. Murder can be stopped.
Tell me exactly what it is you're looking for.
Well, you ever get any false positives? We are arresting individuals who've broken the law.
But they will.
The fact that you prevent it from happening doesn't change the fact that it was going to happen.
The system can't be wrong.
You say something too?
No, you're in a lot of trouble, John. I have a warrant in my pocket that says murder. Don't run.
You don't have to chase me.
From 20th Century Fox
He set me up. He set me up.
and DreamWorks Pictures.
Who's the victim? I've never heard of them, but I'm supposed to kill him in less than 36 hours.
He's coming here. Tom Cruise
I need your help. Give me some information. I need to know how to get at it.
in a Steven Spielberg film.
I have to know. I have to find out what happened in my life.
You tell me, who was it who set this up?
I don't know. How about now?
On June 21st.
So that gives you a flavor for what happened. And as you can guess, as this system found was useful to taking down criminals, society started to believe that, well, this is always going to tell us who the criminals are. We can trust it to take care of criminals for us. We can even arrest these people before they commit the crimes instead of after. But that meant that as they became more and more dependent on this technology, they started believing it, even when it was wrong or when it was manipulated. For a more innocent example, think of Facebook's People You May Know feature. You get the idea that if it's been convincing for you in the past, you might start thinking you know someone even though you don't. And so it can be potentially embarrassing for you that the algorithm, the suggestion, has misled you into friending perhaps someone that you don't know or don't wish to friend. So here's the key that I really want you to know, kind of for test purposes and for material in this class. The first is design bias, that on purpose, this algorithm or this technology has been created to discriminate, and it does it as a feature, not a bug or mistake. So the way the design bias works is I'm going to zoom in on this advertisement. So this was a job ad posted by Verizon. And the problem was that the way this job ad was set up is that it was set up to be shown only to people who are 25 to 36 years of age, who live or are near Washington, D.C., and who are interested in finance. So you can immediately think of some people who might want this job who are unfortunately locked out. You yourself might be one of them. After all, you're under 25 most likely in this class, and you would not be shown this ad because you don't have the 3 years experience, perhaps, that they put in there to make someone 25 or older look at this ad. So there's clear age discrimination here, and it was created to be that way. So you, of course, should be upset at this type of design bias where you're being excluded on the basis of age, that they think you're too young, even though maybe you graduated college at 20 and you have 3 years experience, or if you're too old. If you're 40 years old and you're working on your degree and you're still fairly young, you're not going to see this advertisement, you can't get this job. So design bias is when the algorithm or technology basically says, don't help these people or give them negative marks. You get the idea. It's set up to do so. And you also get the idea here. Unfortunately, part of the problem is that the clients themselves pushed for this. Verizon, of course, told the company placing these ads, the Arlen Group, that we want younger people, younger blood in our company, and so show this to younger people on Facebook. Then another type of this bias is user biased, where people who are creating this by manipulating the algorithm or technology to be mean or specifically biased toward people. So here's an example that's a little drastic, but in this case, so this particular AI robot has been convinced that the Holocaust is not real, and so people told it enough times the Holocaust isn't real, they essentially started saying it back. So you have this type of work, and this is kind of a little bit more of a made-up example where naturally Tay is a robot, no one specifically was necessarily hurt, but you can get the idea that if people, for example, start raiding a grocery store owned by an immigrant with low scores intentionally to hurt that person's business, that would be a great example of user bias as that person gets low Yelp scores or low ratings on Google. So we're going to pause for another MLK quote. And so the other thing I really want to key in on is that it's not just about skin color or age or things like that. Oftentimes these algorithms specifically discriminate against the poor themselves. And so that's a key part on why this is such a problem. Often, unfortunately, this weight goes on those least able to bear it because they already are rather poor, and then these algorithms technology prevent them from some benefits. So this is why war on poverty and eradicating poverty was so important for MLK, especially later in his career. So here's kind of a story of how this can quickly, for a business that is trying to optimize its profit, they can quickly become unethical and cause problems. So the problem was that the deal with the city is set up so that the city does not have to buy the full red light camera. Instead, and this fellow is the one who kind of discovered a lot of the problems, instead, the city gives Xerox part of the money from the tickets instead of having to pay all the money to buy the expensive hardware and run it themselves. So what do you think is going to happen if the city is going to give Xerox more money if the city gives more tickets? Well, naturally, now Xerox and the city are going to want to write a lot more tickets. So as a result, you had this kind of thing happening. He said, look, these cameras are being set up more in areas that are poor in this particular city. And in fact, now the yellow lights are only 3 seconds long, whereas places without the cameras, they're 5 seconds long. So think of it. You're going through an intersection, you see the lights start turning yellow, and you see the camera there, and you're poor already, so a ticket will be quite expensive for you. And then you suddenly see it turn red faster than it's supposed to by a good 2 seconds on average. So you try to speed through the intersection, of course, because you can't afford a ticket. Then you have an accident, possibly fatal, and so these tickets were very damaging. In fact, the story goes on to say that this gentleman, in fact, there were even attempts on his life, and he feels that he was targeted by either the city or Xerox for bringing this to light. So this is a real unfortunate way. This sort of thing should make you angry that technology and algorithms claim to be fair, claim to be keeping us safe, but often are creating different types of bias and often against those least able to handle it. And so he's also got in prison because he cut some of the camera wires himself so that they would not be operating anymore in these areas. And so here's another area where bias could occur. One of the problems is that this was a system in Pennsylvania to help identify children who could be abused. But the problem is, of course, sometimes it's a false positive. So the way the system might work, it might say, well, if you're in a particular zip code and you're in a particular minority where more children get abused, and your parents are a particular poverty level, or you only have one parent, then you might be more likely to be abused. But you can stop and think about the problems with that type of approach, how it could make perfectly safe children be watched by the state, or somehow the state would intervene in these households, and the problems with this type of screening. So it's well meant, of course. Ever since the horrible Sandusky case with abuse against children, Pennsylvania has been much more sensitive about trying to get proper defense of children. But as a result, you have this design bias where, for example, families who are on assistance might be most likely to be flagged as potential abusers, which is not necessarily fair to them or their children. And so you also see two ways where it can be biased. One is more design biased, that it can be set based on your zip code. It claims you're more likely to abuse a child because it's a poor zip code, or even a user bias, that maybe people who have a certain minority, you see the example there, they're more likely to be accused of abusing their children, whereas other types of races are given a break and not considered abusers. So that in itself is unfair. So you're probably already having a lot of opinions of this one way or another, and we'll talk about this in class. But I want you to think also that I've intentionally neglected some examples, but that I'm aware that they exist. So unfortunately, to kind of give every case would get a little heavy, but definitely there are some different examples. And also, I understand that some of these are a matter of debate, how much of a problem it is or isn't. We could talk about affirmative action all day long, is the right approach being used mathematically, but I'm trying to highlight more the obvious bad examples more than anything else. So here's some thoughts for you, things that you can do before class. So I'm going to give you a chance to take a look at these more closely. I want you to think about ways that technology that you're aware of can be user biased or design biased. Specifically, you might want to think of some of the filters. There's been some controversy, for example, of the way that Snapchat lightens or darkens things, or the way it changes faces. Subtle ways that this could be bias. So for example, if Snapchat says, well, we're going to improve your looks, and the filter used to improve your looks features a thin nose, is that in some ways racially biased? Obviously, different races might have different nose thickness on average. And that sounds small, right? But if you really start thinking about it, if you have a larger nose, you should perhaps be upset about this, that there's a clear bias here towards certain types of looks that go with certain types of races or gender or so on and so forth. And also feel free to try the exercise there with the Google Arts and Culture app. So after you've thought about this for a while, let's look at some of these other examples. So another example of biases that you should kind of consider are what happens with your credit score. How is that fairly done? Are there ways perhaps, for example, there that you could be improperly measured? There's so-called redlining in terms of, have you thought about how your zip code plays a part in what your credit report is? It certainly does. You can think also about how does your neighborhood, your neighbors, what street you live on, all of that could be information that helps shape what your financial score is. And some of this should bother you in terms of that a lot of these ways that the reports are created are relatively arbitrary and can be gamed. And also another problem is that unfortunately some of the bias we find, the design bias and user bias in algorithms, is because we ourselves are biased. So here's one example that you might not have thought of. Let's suppose that artificial intelligence is taught about our world using Google News and using various news articles about how people work and about kind of how society, the connections between words, all of those are done. So one problem is that the algorithm started having a bias that when it saw male names, it was more likely to think that they were executives. And when it saw female names, it associated them more with marriage. Now, there might be several reasons, of course, why that's so in the news, why it's covered that way. But I hope you can realize, especially if you're a woman, that's not very fair if AI just kind of learns that you're less likely to be in a position of management and just kind of sees you as some person to be married. And then also, for example, unfortunately, when African American names were searched for, they came up with more negative connotations in the database. And so as a result, it started thinking that European American names were in some way superior. And so you get, again, the problem with this, that this should be a real concern, that sometimes this uncovers, algorithms and technology uncover the bias that is already present in our society. And so that's why this particular MLK quote on technology is one of my favorites of the quotes I picked, that modern man has to be careful not to have a poverty of the spirit, even though we have so much technology and so much science that we can use to implement and to work on humanity. Okay, so just about 10 more minutes here. This is a Google story. So they had this Google Photos tendency where you could match and label different items in the photo. It would be identified by their system. But he's going to explain to you why this created some bias toward his friend who was mislabeled by the Google app. And I'm just going to play the first minute and a half for you. And he's going to explain why he thinks there wasn't necessarily a black person on the team that helped come up with Google Photos.
Can computers be racist and sexist? Well, yes, they can. And that's the topic of this week's All Tech Considered. It's a case of garbage in, garbage out. People have biases, so when they write computer programs, those programs can have biases too. NPR's Laura Seidel is at the South by Southwest Interactive Conference where tech experts are talking about that problem.
Jackie Elsinay was at a concert with friends and he took a bunch of pictures. Later, he loaded them into Google Photos, which stores and automatically organizes images. Its software is able to group together pictures of a particular friend or pictures of dogs together, cats, etc. But when it labeled a picture of one of Elsinay's friends, it left him speechless. Both he and his friend are African American.
It labeled it as something else. It labeled her as a different species of creature.
You can't even say.
Yeah, I kind of refused it, more or less, because I don't want to accept. By saying that, I kind of like reinforce the idea of it, so I kind of try to pull away from that.
I'm not going to reveal which animal it labeled his friend. It also happened to others with dark skin, and Google has apologized and fixed the problem. But Alcinate isn't buying that it's just some weird technical glitch.
One could say, oh, it's a computer. I'm like, okay, yeah, computer built by whom? A computer designed by whom? A computer trained by whom?
Alcinate's conclusion is that there probably weren't any black people on the team that designed Google Photos. Google says it did test the product on employees of different races. Alcinate's experience...
Okay, so you get the idea? And so you can see part of the problem here, naturally, is that companies have a responsibility for what their technology does, and they can't just claim, oh, it's an accident, or, oh, well, we didn't think of that. And you see some other problems here that could be user bias related. So some of the quotes here that are also on the rest of the audio, searching for an African American name might be more likely to bring up ads for criminal record searches. And so you might say, well, that just reflects what's going on in the market, but should it, honestly? So just because people are bigoted, should your algorithm or technology reflect that bigotry 100%? That itself is a problem that you might want to think of. And then you see another issue here, that women are more likely to be shown lower paying jobs than men in online advertisements. And so naturally, if you're a woman, this should upset you. The idea that for whatever reason, even if women do tend to get paid less, or maybe even are willing to take a little less, it shouldn't be the default. Certainly there are some women watching this video who would like to make more, not less. And so as a result, you can see what's the problem with Google having this user bias. And of course, a little bit of both. It's user bias in which maybe the people searching for these things have made Google think this is what you'd find, or it's design bias that Google doesn't have some sort of adjustment factor there to make sure these things don't happen. But unfortunately, the two merge together and create the problem that your searches on Google and other sites might be biased. And then here's another unfortunate problem. So think about it here. There's a lot of examples like this. So the site Nextdoor is supposed to be a site where people can keep track of what's going on in their neighborhood, buy things, sell things, maybe keep out, alert if a pet is missing, you get the idea. But it can also be used, unfortunately, for racism. So for example, suppose that there's someone riding their bike in the neighborhood who's of a different race or type than is normally in the neighborhood, and now you have like very kind of accusatory posts, as if there's something wrong with someone just being in a neighborhood, not doing anything but riding their bike, right? So that's one of the problems often, is that you see racist or sexist abuse, and often the alert systems are not well configured to take care of it. You also see kind of the opposite of this on Twitter, where a lot of women complain that they are abused verbally and Twitter never does anything about it. That apparently Twitter's standards for confronting abuse and making sure it stops are much higher for women. They won't do anything for women as much as they will do for men and others who complain. So you get the problem there, that a lot of these alert systems are, of course, human kind of measured and built, and for whatever reason can be misused by humans as well due to user bias, where they claim that there's something wrong with this minority person being in my neighborhood, or that this or the other side that I told you about, where women complain of bias and they're not taken seriously. In fact, kind of on an unrelated topic, there's even some research saying that in the medical community, women who complain of pain are not taken seriously enough compared to men, and that that's unfortunately another problem in terms of how people are not given their right treatment based on what's happening to them, and that who they are as a person is creating differences, and unfair ones at that. Okay, so I've shown you a lot of different examples. I don't want to overdo them all too much, but you get the idea of user bias and design bias. I definitely want you to know those and be able to give me examples through the slides. And also, talking a little about the future, you're going to see more and more algorithms technology are going to determine your future. I'm sure in some small way an algorithm played a role in whether you got in here or other colleges or not. It's only going to intensify in the future. When you go up for a job, using the right words on your resume, being from a certain school or not being from a certain school are going to have a big influence on where you'll go next. So the problem is, as we have more and more algorithms taking charge of how much time people spend in prison, who gets promoted and who gets fired, all of these highly important topics, we need to spend even more time thinking about the effects. And so I encourage you, think about it when you create some sort of policy in your company or some sort of math is done, ask some hard questions. Would this discriminate against someone just because they're from this area or they have this skin color or they, do this thing? So be sure to kind of consider that in advance. Think about too voice assistants, for example, as that type of artificial intelligence becomes even more popular. What is that going to mean in the future? So what should you do about all this? Well, for one, you might have to game the system. So this is why, unfortunately, I see this more from Asian students, from international students, might change their first name to something more westernized. And it's kind of sad to see that, but sometimes that's a necessary strategy to help them assimilate more or to get their resume to have proper acceptance. You might want to think twice about accepting math, about how the world works, or technology. So for example, if you only want to hire people who graduate from college in 4 years, that might lock out people who paid their own way through college, which meant it took them 6 years, and people who kind of had to take more time to go through college might have lacked more financial support from their parents because they're more poor, and then maybe as a result were from a minority background or disadvantaged in some way. So that's one of those subtle things where you might think, oh, well, it's a great rule to use that I'm only going to hire you if you graduate from college in 4 years. But there can be kind of ways that can be discriminatory or lock out candidates from a certain background who can do just as good a job as people who graduate in 4 years. And then finally, one other thought, push back when people try to flag, of course, people just because they don't like their gender or sexuality or whatever it may be on social networks. Try to push back from that happening, give them the thumbs up, not the thumbs down, so to speak, and be aware that that is a unfortunate trend that happens with these algorithms and technology. So, one last MLK quote. And I look forward to hearing additional comments from you. Thanks so much for your attention. And I thank, of course, Dr. Paul, Dr. Williams, Dr. Albert, and others who assisted me. And I look forward to coming back and speaking with you all when I'm back in town. And I appreciate you watching the video. Make sure you know the differences between user and design bias, some of my examples, and have an idea of how algorithms and technology can be misused and ways to stop that from happening or to defend yourself. That's all I have for you. Thank you.